Negative numbers create some issues when we're talking about powers and roots. I shouldn't say issues, they create special cases. And the reason being is because if we have a radical, you know, we've dealt with I in terms of imaginary numbers and when they exist, but that was when we were dealing with just a square root. You know, how does it look if we've got a cube root or a fourth root, fifth root, you know, etc. And what do, just as a refresher on our exponent rules, what do negative exponents mean? Okay, so there's two types of situations here. So let's say that I have negative 3 to the power of 1. That's going to be a negative 3. But if I have negative 3 squared, it's going to be a positive 9. If I have negative 3 cubed, it's a negative 27. So basically what's happening here is when it's an even number as a power, it's going to be positive, because we've got a negative times a negative, which gives you a positive. In terms of when you have a negative with a odd power, it's going to be a negative number. Now, the thing to remember, your calculator, if you don't put parentheses around that negative 3 before you square it, the calculator is going to give you a negative 9. You need to think about this in terms of, okay, what is negative 3 times negative 3? It should be a positive number. A lot of people just type it into their calculator without those parentheses, and they take the calculator's word for it. That's an operator error, just an FYI there. Okay, so these are positive exponents. Well, what happens if we've got negative exponents? So let's say I've got negative 3 to the negative 1. Now remember, with negative exponents, this flips it and creates it a fraction. So this is now 1 over negative 3. Just because you have a negative exponent and a negative number does not mean it comes out to a positive fraction. So the only difference here is a negative exponent just flips the fraction. So if I were to have negative 3 to the negative 2, that's going to be a positive 1 over 9. Negative 3 to the negative 3 is going to be a 1 over negative 27. Okay, so just because you've got the negative exponent does not mean that it's going to be a positive number. Okay. Now, that's dealing with exponents, and that should be just a refresher because we've done our properties of exponents. But when we have a negative radical, this is where it gets a little tricky. So like I said before, when we were dealing with square roots, we had to, if we had a square root of a negative number, so like if I had the square root of negative 4, this didn't actually work in terms of real numbers. We had to put in an imaginary number. So this would have been negative, well, not negative, 2i, right? So that's going to help us kind of determine a little bit whether it's even possible. Looking at this, our root here is a 2. It is an even number. So here's kind of the rule of thumb. You don't need to erase this, I'm just erasing it for space here. The rule of thumb is if the nth root of x is odd, then it's defined. Well, I shouldn't say defined. It is real. It is possible. If square root n is odd, that doesn't make sense in terms of, or n is odd, then it's real. If n radical sign x, or n is even, this is imaginary. If I can spell imaginary, holy cow. All right, so determining whether it's going to be a defined or not defined type of situation. I kind of said that a little bit too early. That just means, you know, is it actually going to be a perfect cube, a perfect, you know, whatever that you happen to be dealing with. So let's say, for instance, that I have the fifth root of negative 243. Okay, so looking at this, I know right now it's a fifth root, which is odd. Therefore, this is real. Okay, so it's real, but we need to determine, you know, is it defined? Is it not defined? So how I kind of look at this is I kind of break down the fifth root of negative 243. And I say that because I split it in terms of the fifth root of negative 1 times the fifth root of 243. And we've dealt with the splitting before when we were simplifying our radicals. So looking at this, the fifth root of negative 1 is going to be a negative 1. So when you have that negative underneath the square root and it's an odd, that just means it's going to be a negative number. So we've got here the fifth root of negative 1 is negative 1. Now we need to look at the fifth root of 243. Just grabbing my calculator, sorry. I don't know this off the top of my head. So the fifth root of 243, if I break that down, is 3. So now I can multiply those two together to get a negative 3 as my fifth root of negative 243. In terms of when it wouldn't exist, would be like if we had a square root of negative 243, because we would have to have that negative number. One more thing, and that's whether it's defined or not defined. Under the defined category, it's defined if n is odd, and we're talking about, you know, n radical sign x. It's also defined if n is 2. Otherwise, it's not defined if n is even and greater than 2. So in that last example, since it was an odd root, it was already defined, so we didn't have to worry about that. But the special case there is if n is 2 or if n is an even and greater than 2. The reason being is because with it having been a square root, you can have that imaginary number, so that's just something to note.